The division algorithm theorem is used to obtain two important facts about the zeros of a polynomial. Those are the remainder theorem and the factor theorem. The division algorithm theorem says that if f and g are two polynomials such that degree of g is at least 1, then f of x can be written as q of x times g of x plus r of x, where q of x is the quotient in the division, r of x is the remainder, and the degree of the remainder is always less than degree of divisor g of x. So if g of x is equal, g of x is the polynomial x minus c, then we can write that any function f of x divided by that binomial x minus c will be the quotient q of x times x minus c plus r of x. However, the degree of r of x is always less than the degree of g of x, but the degree of g of x is simply 1. So that means that degree of r of x has to be 0, and that means that r of x is a constant, and therefore we'll just skip the x and just write r. So for the case where g of x is equal x minus c, we can write that f of x is q of x times x minus c plus r. And we'll use this to justify the first theorem, that it is the remainder theorem. It says that when f of x is divided by x minus c, then the remainder is f of c. So we'll just repeat what we just said, that f of x is equal q of x times x minus c plus the remainder, and if x is equal c, we get f of c is equal g of c times c minus c plus r. Because c minus c is 0, the whole term is 0, and that sum is simply equal r. So we have that f of c is equal r. The second theorem, the factor theorem, says that if x minus c is a factor of the polynomial f of x, then f of c is equal 0. And if f of c is equal 0, then x minus c is a factor of the polynomial f of x. So if we assume that x minus c is a factor, then f of x can be written as x minus c times some polynomial q of x. And therefore, the value of that polynomial at c is going to be c minus c times q of c, which is 0, since c minus c is 0. Now, if f of c is equal 0, then the remainder when dividing by x minus c is 0, and therefore we can write then f of x is quotient times x minus c plus the remainder. But since the remainder is 0, this is the same as q of x times x minus c. And that simply means that x minus c is a factor of f of x, because f of x can be written as a product of x minus c times some other polynomial.